So, welcome to the course Digital Human Modeling and Simulation for Virtual Ergonomic Evaluation. Now, we are going to discuss this module for week 4, Introduction to Digital Human Modeling and Simulation. So, in the last 3 modules, 1, 2 and 3, we discussed various aspects of design, ergonomics, virtual ergonomics. Now particularly we will discuss about digital human modeling and simulation in module 4. In module 3 we mentioned what is digital human model. Just for recapitulation, we are again discussing that what is digital human model. CE in 2003 define digital human model as this is computer graphics mannequin or digital human model. It can be defined as a 2-dimensional or 3-dimensional graphical computer representation of human body based on anthropometric measurements, link and joint structure and movement characteristics. In other words, we can define what is digital human model. Digital human models are 2-dimensional or 3-dimensional representation of human body based on anthropometric and biomechanical data, and those models are used for virtual ergonomic evaluation of product and workstations. These digital human models are of 2 types. First one is physical and second one is cognitive. So here is one example. These digital human models, male models and female models, created using JAX software, where we can see that different population databases are already incorporated in that software, and based on those databases we can create digital human model. So digital human model is of 2 types. One is physical human model, another is cognitive digital human model. Now what is physical digital human model? Physical digital human modeling is concerned with physiology, anatomy and various occupational ergonomics aspects. Physical digital human models again we can categorize in 2 categories. One biomechanical model, and another is 2-dimensional or 3-dimensional structural model. This biomechanical model, we discuss about various softwares are there. For example, 3ds SPP, ErgoWatch, NIOS and Snoop tools. So all these are coming under biomechanical model. And under 2-dimensional or 3-dimensional structural model, we discuss about various 2-dimensional or 3-dimensional representation of human model, human body form. An example of such softwares are JAX, SAMI, Ramses, SafeWord, Delmia and so many others. So overall, this physical digital human model mainly concerned about biomechanical aspect, anthropometric aspect, and while we are evaluating any workstation, we are checking the human compatibility with the machine. We use this type of physical digital human model. But the digital human model which we are discussing in the present course, that is mainly related to 2-dimensional or 3-dimensional structural model. Next, another type of digital human model is cognitive digital human model. It is still in development phase because in many universities and research organizations in this particular area research is going on and new research findings are coming out. So this cognitive and or performance digital human model, what does it deal with? Cognitive and performance digital human modeling and simulation of human beings include modeling and simulation of human behavioral aspects, artificial intelligence, interactivity of synthetic agents, etc. So these are the areas which cognitive digital human models deals with. Example of such softwares are CASE or Computer Aided System Human Engineering Performance Visualization System PVS, then NASA TLX and so many others. But these softwares as well as overall the cognitive or performance digital human models, these are still in primitive stage and enough research is required for developing this particular field. Now, evolution of digital human model. When this digital human model started and gradually years after years how it evolved. So, if we look, initially digital human models were developed as stick figures. More complex representation of body segments and joints with finer details gradually came. Next, physical digital human models usually constructed on the basis of rigid framework or link segment. Framework usually covered with solid geometric shapes to give visualization of human body surface. So, initial it is rigid framework of link segment, then gradually it is solid geometric shapes. So, these solid geometric shapes, earlier those models are robot-like because in the software geometric primitives like cylinder, then different types of polygons, then sphere, all those basic forms are used. Gradually, with the advancement of computer technology, complex geometric models and smoothing algorithm came. Then it is possible to develop body shapes or morphology with surface modeling. Later on, the surface geometry were further developed, which represented human skin, then various types of clothing, protective equipments. Those types of development happened in this field. And more recently, in this software, CentOS, it is developed by Virtual Soldier Research by Iowa University. In that software, we can find very realistic skin deformation, contracting muscle in very advanced digital human model gradually came in the market, which initially started with stick figures. Now, advanced digital human model softwares are available where we can go for various types of virtual ergonomic evaluation, and those models are very realistic in terms of anthropometry, in terms of body motion, in terms of various analysis, and also as for look also. So, if the whole whatever we discussed in earlier slide, the whole information, if we summarize, it moves like this milestones. So, initially it was stick figure, then geometric primitives are used. Gradually, complex geometric modeling with smoothing algorithm came. Surface modeling for appearance of skin and clothing, it was started. Then incorporation of 3D body scanner data directly. Earlier for digital human model, physical anthropometric measurement and those data are used for this purpose, but nowadays directly we can import the data from 3D body scanner, and those data is used for developing digital human model. So, those digital human models are much more realistic. Not only 3D body scanner, then 3D motion captured data, human motion in 3D space, that has also been captured with camera, and those information is incorporated in for posture prediction, various types of activities. So, that is also included in this digital human model software. So, technology like 3D body scanning, 3D motion analysis, all those are now being incorporated in advanced digital human modeling software. Then incorporation of predicting dynamic human motion for realistic posture and task simulation, that is also done. Realistic high fidelity digital human models with finer details, as for example skin deformation, muscle contraction, that is also going on by various software developers. The whole evolution can be represented like this type of diagram. So it started from stick figure, then geometric primitive, then it moves towards wireframe, then various type of shaded representation only for the skin and body shape, for showing the body shape. But not only that body shape, or after that gradually it moves towards this type of skeletal figure, not only skeleton, on that muscles also. So for example, in anybody's software there is muscle also. After that, more realistic representation like skin deformation, clothing deformation, clothing pattern. So all these things gradually being incorporated in various digital modeling software. So among the advanced software, one is Santos, where we can find all these realistic skin deformation, then muscle movement and all. Now next we are moving towards the history of various digital human modeling software which developed years after years, started in the long back like 1960s by Boeing Corporation USA. They developed the first digital human model which is known as Boeman. So we are starting from that software Boeman. So if you look at those models, you will understand those models are very primitive in nature. The first virtual mannequin named First Man, later on it was named as Boeman, was developed by Boeing Corporation USA in 1959 to assess pilot accommodation in the cockpit of a Boeing 747 aircraft. The First Man was composed of 7 movable segments which could be articulated at pelvis, neck, shoulder, elbow in manners resembling to human motion. The First Man evolved up to 4th generation, that is 4th man and woman version, as it is found from the information provided by Model 1998. The First Man was also the first virtual human used as animated human for commercial purpose. So this is one image from that software. Next, after Boeman, now there are so many other software, Cyberman, Sammy. So one of the first was the DHM software was Cybernetic Man Model Cyberman. Cyberman was developed in 1970s by Chrysler Corporation for their in-house design and evaluation of automobile. Then other software like SAMI came. SAMI, full form System for Aiding Man-Machine Interaction Evaluation, is a computer-aided human modeling, ergonomic design and evaluation of system. Developed by Design Ergonomics Group in collaboration with Wolfson School of Mechanical and Manufacturing Engineering in 1972. This is one of the first kind computer-based digital human modeling program for ergonomic evaluation. It consisted of well-developed vision system and manipulation of complex objects. So after Boeman, Cyberman, SAMI, so many other softwares also came in the market. One software is CombiMan, computerized biomechanical man model known as CombiMan. Later on it was known as CrewChief. Was developed by University of Dayton, and further development took place in US Air Force Medical Research Laboratory AMRL during early 1980s for simulating pilot and aircraft maintenance tasks. So in 1980s CombiMan software came. CombiMan as both illustrative and analytic software which is capable of analyzing physical accessibility, reach and fit capabilities, strength for operating control and visibility, accessibility, etc. Then gradually more advanced software came. In mid 1980s, N. Butler and his research team developed the software Jack. This is a computer graphics software where now it is being marketed by Siemens PLM solution. The Jack software, initially it was known as Tempest, and it was developed by Human Modeling and Simulation Group, University of Pennsylvania, and it was funded by NASA and US Army. And if you look at the models, so this model relatively more realistic than the earlier models. In this 1980s, 1990s, during this period, other software also appeared in the market. One of such software is Ramses. The realistic anthropological mathematical system for interior comfort simulation, known as Ramses Model, and it was developed in 1980s. It was developed as a cooperative arrangement between German automobile manufacturer and Technical University of Munich, Germany. So, by collaboration of this TechMath and University of Munich, this software came. Ramses is used extensively in automotive industry, from various types of passengers, starting from passengers car to heavy vehicle, as well as even for aerospace industry. This software is being widely used nowadays. Another software, SafeWork. SafeWork software was developed by SafeWork Inc., business unit of Dassault System. It can determine various variables such as lifting, lowering, pushing, pulling, weight limits suggested by Nai's lifting equation. Some other software, as it is mentioned here, Mannequin Pro. Mannequin Pro is a PC-based human modeling software. It is available since 1990. Mannequin Pro was used by Air Operations Division in late 90s to assist in the evaluation of pilot in a Black Hawk helicopter. So, how these models can be used for helicopter cockpit simulation, it has been shown by authors, as in case of, you can go through this reference, then we will get more information. Another software known as LifeMod. It came to existence around 1990s with constant development over 2 decades. It can be integrated with other software like MD, Adams. LifeMod has powerful post-processing capabilities to produce standard plots of force, displacement, velocities, accelerations, torques and angles. Using a 3D motion capture system, we can also incorporate human 3D motion data to this software, and we can create lifelike the motion of digital human models. So, down the line, another software, this Anybody, it came into existence and became popular during 2000. The Anybody Research Group was formed in 1997 at Aalborg University in Denmark and globalized around 2002. It helped to build more complex whole body model and developed ergonomic optimization in design. 3D biomechanical model that was based on the theory of mechanical structure of the musculoskeletal system shows a mathematical resemblance to a solid articulated structure in which the load-carrying elements, bones, muscles and ligaments are used to their full potential to stabilize the configuration of the structure. So in earlier models, what we find? Earlier models we find that is mainly either link segment or link segment and skeletal structure is covered with surface modeling to represent the human skin or shaded model. But in this model, what we can find, with the anatomical bony structure is covered, skeletal structure is covered with various muscles. Even with this software, we can create models, any-body models that may be composed more than 500 individual muscles. So while we are discussing or while we are going for analyzing various types of biomechanical analysis, then this software is very much helpful, because there we can analyze the full potential to, then we can analyze the motion of bones, then muscle contraction, activity of ligaments. So all these things can be analyzed using this type of software. Most advanced among this available software, what you find, that is in terms of features, the software is called Santos. The Santos was developed by University of Iowa, and in 1998, and it was funded by Virtual Soldier Research by US Army and University of Iowa. Under the project Virtual Soldier Research Group, they developed this software. This software right now, among those available softwares, it is considered as one of the best software, because in this software we can find the skeletal structure covered with surface model, and it includes realistic skin deformation, contracting muscle. All these things we can go for physiological evaluation, biomechanical evaluation, effect of various environmental variables. Those can also be studied with this software. So this is really an advanced software. The software package, the Santos software package includes biomechanical models and simulation of human motion, posture prediction, strength, fatigue, and also physiology. So this information, you can get more information from this reference, Ritchie 2011. Now, so what we discussed so far, we discussed about how digital human modeling software evolved starting from 1960s still today, and various digital human model softwares which came in the market in different time period. Now we are moving to interfacing CAD product or facility with digital human model. How we can do that one? So this schematic diagram proposed by Patel et al. 2016. So what they proposed, what input is required? CAD. From CAD software, where we can consider various design variables for machine tools or any other equipment or device design, and considering all those variables, we can create the CAD model of the product or any other facility. So in this side, using CAD software, we are developing CAD model. On the other hand, we are developing digital human model. Using digital human modeling software, various human factors variable related to anthropometry, related to biomechanics, we can consider and we can create human model. When this product CAD model or facility CAD model is ready and human CAD model is also ready, then we can go for interfacing those. Interaction between human and product. After that, we go for various output, simulation parameters and simulation analysis. So after analyzing, we can go. So this step is for virtual ergonomic evaluation of that product or workstation or any other facility which we are developing. So details information regarding this reference you will get at the end slide. Now if we represent the same thing in schematic diagram, so what we do with digital human modeling software, where you can use anthropometric data as well as biomechanical data. For initially it is used anthropometric data, we can create this type of digital human model. Even we can change the various biomechanical variables also, like range of motion, comfort range, also those data we can fit in these types of digital human model. And when the digital human model, we can earlier also discussed, we can create customized human model. Customized human model means we can create as per age variation, sex variation, anthropometric variation as per various percentile data. So here it is shown that 5th percentile Gorkha soldier from India, then 50th percentile pool data of army, and 95th percentile Sikh Punjabi soldiers from Indian army. So these are the representative of smaller Indian army personnel, average Indian army personnel, and larger Indian army personnel. While these models are ready, then what we are doing, we can generate solid model of this type of product or facility. Here it is a army vehicle. In army vehicle, this type of army vehicle we can create, or any other product or facility we can develop using either with the help of this type of digital human modeling software, but many digital human modeling software does not have such capabilities to develop very complex CAD model of the product or facility. For that purpose, what we do, we develop this type of product model from other CAD software like SolidWorks, CATIA, Unigraphics. So this type of various ideas, so various softwares are CAD softwares are available. With those CAD softwares, we can create this type of product or facility model, and we can import those model in digital human modeling software. Then what we do, we go for interfacing this digital human model with the product or facility or vehicle model or workstation model. For that purpose, what is required? We have to give appropriate working posture in that workstation, in that facility. What's the activities, required activities those human models is required to do, that type of posture we have to give, and we have to position those human models inside that workstation or that facility. While human models are properly positioned, then we can go for various types of virtual ergonomic evaluation. We will discuss what type of ergonomic evaluation we can do with this type of software, with this type of digital human modeling and CAD software. So if we repeat, so first we are creating digital human model of various percentile, or even we can create as per individual data. At the same time, we are either creating this type of product model using digital human modeling software, or we are importing this type of CAD model of the product made from other software like say Unigraphics, CATIA, SolidWorks. After that, we are importing that model to that digital human modeling software interface, and we are putting those human models with appropriate working posture. Then we are moving towards ergonomic evaluation. Now here we will discuss one example. In this example, for tractor cab design, so this is taken from Patel et al. 2016 schematic representation of ergonomic evaluation of a 3D tractor cab model with digital human model. So how we do that? If we want to evaluate a CAD model of a tractor in virtual environment, how should we proceed? First, database required farmers or tractor operators related database. So anthropometric, that is static and dynamic dimension is required. Then biomechanical information, biomechanical data related to range of motion, force, torque, etc. required. Then comfort range, single joint, multiple joint comfort data is required. So these three areas, anthropometric data, biomechanical data and comfort range data. While these data are ready, with those help of those data, we can create digital human model. Digital human model of tractor operator or farmer who will operate the tractor. While that human model is ready, then what we are doing? Human motion simulation, that information creating virtual 3D human. That information also we can put, and we are creating 3D virtual environment. So from this side, based on this database, we are developing digital human model of tractor operator or farmer model. On the other hand, we require cab information, the tractor cab. For that purpose, we go for need identification, design limit selection, various design. Those design limit selection mean various dimensions, material selection, cost, all this. Based on that 2D sketches and concept development. While the concept development is ready, then we are using various types of CAD software. With those CAD software, we are developing the 3D CAD model of that tractor cab, and also we are rendering that one. So digital cab model of the tractor, design variables like driver seat, steering wheel, various types of foot controls, hand controls, display dashboard, all those are made. So from this side, digital human model is ready, and from this side, tractor cab model, 3D CAD rendered CAD model is ready. Then we are interfacing. Digital human models are given actual working posture and CAD model, and it is that models are positioned in tractor cab model. So we are getting that virtual environment. In this virtual environment, both digital human models are present and tractor cab model is also present. While that virtual environment incorporating CAD model of the product and human is ready, then we are moving towards ergonomic analysis. What ergonomic analysis we can do? We can go for various types of ergonomic evaluation for this tractor cab. For example, we can go for vision analysis, interior and exterior visual fields from driver's seat, reach analysis, reach towards various types of foot controls, hand controls. Then working posture, driving posture, driving comfort, clearance interference, ingress egress, whether the driver can easily enter or come out from the driver cabin, and various other analysis we can do. At this phase, if we find after evaluation with digital human model, if we find that whatever concept model we develop, if that is fine as per the ergonomic evaluation, then we will proceed for final design concept and prototype making. If we find no, there is some modification or redesign is required, then again we will go for redesign and modification phase, and again we will modify the tractor cab model, and again we will go for further ergonomic evaluation. While ergonomic evaluation is satisfactory, if we find that tractor cab model has been designed as per various human factor issues, it has properly incorporated or it has been developed as per various human factor issues, then we will go for prototype making, and finally is documentation. Now, what are the functionality of digital human model? So basic functionality of any of these digital human modeling software, whatever softwares we just discussed, that may be Jack, that may be Sami, Ramses or Santos, for all these softwares, basic functionality is creating digital human model. Well, regarding this digital human model creation, we, as we mentioned, we can create customized human. Human model as per our intended user population or intended user, and any sort of variation in terms of anthropometry, somatotype, we can do that. Then we move towards building virtual environment. Virtual environment, making the CAD model of the product or importing the CAD model of the product or workstation from other CAD software. Other CAD software develop workstation model, and interfacing these two, human model and virtual environment or virtual product model, then we interfacing with appropriate posture. So these three are the basic for any software. Then software to software other functionalities varies, but few basic functionalities are there in almost all these softwares. Those include reach analysis, vision analysis, clearance interference study, comfort discomfort analysis, fatigue analysis, various types of postural analysis using various types of postural tools like ruler, reba, wash, knives, etc. Then posture prediction based on preset criteria, lower back analysis, spinal compression forces, shearing forces we can analyze. Not only that, even metabolic energy expenditure, predetermined time standard, static strength prediction, various type of packaging guidelines as per Society of Automotive Engineers or any other standard organization, as per their requirement we can also analyze our product or workstation. So these are the some basic functionalities which is available almost in all the developed software which are right now in the market. Now, Stephen and Jones 2009, Bob and Fritzke 2009, they mention digital human modeling or digital human models or digital human model software has the capability to interact with digital workstation, and subsequent various types of ergonomic evaluation is possible. As ergonomic evaluation, they mention we can study workstation layout, workflow simulation, assembly accessibility, reach analysis, clearance analysis, strength capability studies, safety analysis, assembly feasibility, others like process compatibility issues, posture and movement simulation for various body parts movement, then inverse kinematic, forward kinematic, different types of kinematics for posture, giving the appropriate working posture or simulating various types of tasks, then vision simulation, then comfort analysis based on single body joint or multiple body joint, then maximum force calculation and center of gravity analysis, biomechanical information, spinal compression. So they mention all these types of analysis actually we can perform with the help of digital human modeling software, and that's why digital human modeling softwares are very much essential for proactive ergonomic evaluation of various types of product and facility in production engineering or manufacturing sector or in production plants. Now we want to discuss how these digital human models are created using digital human modeling software. So software to software it varies. From one software to another software, interface is different. You will find in some software we can create that user interface is very user friendly. In some software it is little bit difficult, you have to learn. So here we are giving example from CATIA software. In CATIA software we can create digital human model. For that purpose, if we open that software, we will find the start menu. Under start menu there is one sub menu called ergonomic design and analysis. Under this ergonomic design and analysis we will find human builder. There are four options: human measurement editor, human activity analysis, human builder and human posture analysis. While we are creating digital human model, we want to create new model, then we will follow this step. From start we will go to human builder. while we will click on human builder, it will open this particular window where so many other tools are there. So first we will use this tool. This tool is insert new mannequin. For inserting new mannequin, while we will click on that one, it will open this type of window. In that window, which informations you need to put, first one is you have to select a product. First, there should be a product tree. In that, you have to identify that human model which you are going to create that is associated with this product one. Now, mannequin name. You can put the name of the mannequin, mannequin 1, mannequin 2, or any other particular name, that 50th percentile model or 5th percentile model, or whatever you wish. Accordingly, you can put the name. Then you can specify the gender, whether that is a male model or female model. Then you can go for percentile, which percentile model you want to create. You can create as per your requirement various percentile, starting from 1st percentile to 99th percentile or 100th percentile. After that, while you are clicking on OK, then this type of models are created. Human model is generated. Now, while this human model is generated, now you can go for further modifying individual body parts based on anthropometric data. For that purpose, you have to follow this path from start, then ergonomic design analysis. Under that, human measurement editor. Then under human measurement editor, when you will click on human measurement editor, this window will open. In that window, you are first selecting this one called filter. In that filter, various parts are there that you can go for part, body, head, torso, arm, hand. In this various body parts are there. Types, what type of anthropometric variables you want to consider, like circumference, height, length, breadth, depth, mass. So all this is possible. Now here we can go for manual. If you want to manipulate it, we can put it manual. Then we can go either one or individually, or we can select all at a time. So while you are putting all, then all the body parts and its all types of anthropometric variables will be displayed on human body, and each of the body segment and its anthropometric dimension we can modify. So here it is shown that how we can to change the dimension of any body part. Double click on that part. If we double click on that one, then this type of window will open. If you will say, for example, here okay, so from front to back, mean if we say this is the head depth, or to back of the protection to back of head, it's not clearly visible. Anyway, so if we want to decide the head dimension, then we can select this particular dimension. While we will click from that list, that will be highlighted, and when that is highlighted, then you will find that variables, areas, values are shown there. Now, as we are manually manipulate that dimension, for that purpose we are selecting as manual. Now, if you want to create which percentile, you can put it here. Otherwise, if you have anthropometric data for that particular percentile or for individual, then you can put that value here. While you will put that value here, automatically it will change the percentile value as per the incorporated database. If the database is not there incorporated for a particular population, then as per the particular population anthropometric data, we can put the dimensional data for specific body parts. Then obviously gender here it is man, and construction this is standing. This is for these dimensions are for standing posture. Similarly, we can find for sitting posture also so many other variables. So here you can find 103 anthropometric variables are there for constructing this digital human model in case of this CATIA digital human model, which is also known as Delmia human. So this is one example from CATIA software. From other software, say now if we go for other software, if we see the interface of JAX software, in JAX software we will find this type of interface where we can put the dimensions. So first we are creating new human model. In that new human model we can create that which human model you want to modify the body dimension. We can put the name of that. We can specify whether we are creating male model or female model. After that, while that human model is ready, then we can manipulate or we can provide the anthropometric dimension for various body parts. Based on that, we can create that human model. While that human model is created, then there are two options. One is basic scaling. So this is coming under basic scaling. Then we can go for body part scaling. Individual body parts it is possible for further scaling of individual body parts. So this is for overall body. Then we can go for only we can further, when that human model is ready, then we can go for further modification or further refinement of individual body parts. Say for example, for lower arm length we can modify the lower arm circumference. For that purpose we have to go for body part scaling. So in this way, software to software there is variation in terms of number of anthropometric variables considered for creating the digital human model. At the same time, various types of anthropometric database incorporated in that software, that is also different for different softwares. So in this way, using different types of digital human modeling software, here only we discussed about the example of CATIA and JAG, but we can use any other software like Ramses, SAMI, Santos. With this type of software, we can create digital human model based on our anthropometric data. Further, again we can manipulate biomechanical data also. There is in all these digital human models, there is options for modifying the joint limit, means range of movement modification. There is provision for defining the comfort joint angle for different body joints. So based on that, we can also modify biomechanical data for that particular human model. Now, as this course, many of the students are from India who enrolled for this course, Digital Human Modeling and Simulation for Virtual Ergonomic Evaluation. So I think many students will be interested to know what's the present status of digital human modeling teaching, research related to education and research, how in India this research and teaching is going on. So for that purpose, I am referring one paper published by me in 2014. So after 2014, if we see, there are 18 publications related to application of various types of digital human modeling software for various types of product or workstation design and evaluation reported from India. Similarly, related to research and development, mean either creating digital human model or modifying its body parts, that type of research, reported research is 8 in number from India. Similarly, literature review based paper or review article published from India till 2014 numbers is 6. So mainly in India, if we see the publication, so main publication is related to application of digital human modeling software for various product and workstation design. But R&D activities are very limited, and also few review based articles are also available. Now I will suggest all of you to download this paper and go through, then you will get clear picture of Indian scenario, digital human modeling and simulation in product and workstation design, Indian scenario. So in India, what research is going on, which are the institutes or organizations doing research and teaching related to digital human model. So here all those informations are there, you can go through. I just want to highlight few areas, like so if you look at this particular section, research and development initiative, so all the references are there, you can go through, you can explore these references, then you will get more information related to research and development initiative related to digital human modeling which are going on in India. So these are some picture from those published papers, where movement of eyeball, then view field related research is going on. Then application oriented. So if you go through all these references, then you will find there is digital human model has been used for posture analysis, design and spatial layout of playing equipment, ingress egress analysis, anthropometric size measurement of Indian driving population, modeling for anthropometry, vision analysis of jet aircraft pilot. So various types of application of digital human modeling, various different digital human modeling software has been done in Indian scenario. Similarly, review based publication, if you look at, so these are some information related to review based paper. So I suggest all of you to go through these references, then you will find more information related to use of digital human model in India. Then if you look at this side, there is a list. These are the academic or research institutions in India which are using digital human modeling software for their research or product or any other facility design purpose. So Center for Design and Management CPDM, IISc Bangalore, Design Department IIT Guwahati, Department of Human Engineering and Human Factor, Indian Air Force. So many other institutions are there who are using digital human modeling software for their research and development purposes. These are mainly academic institutions or research institutions. Other research and development organizations like Defense Institute of Physical and Alliance Sciences, Delhi, Automotive Research Association of India, Pune, Hindustan Aeronautics Limited, Bangalore, Aeronautical Development Agency, Bangalore. So these are various R&D organizations which are using digital human modeling software for their product and facility evaluation. Then various industries. Here are few industries names are also mentioned. So from the literature, it is found that in these industries also digital human modeling software has been used for their either their manufacturing shop floor or various types of product evaluation. These industries are using digital human modeling software. So from this paper, we are getting detailed information related to use of digital human modeling software for research purpose or teaching purpose in India, and number of paper published in various fields. Like this one, review paper, R&D related, research and development related papers, and application related papers. Now, various online useful resources. These are the softwares available in the market, and these are the links of those softwares web page. If you explore these websites, then you will find more information related to individual software, their capabilities, their limitations, as well as when they are developed, how they are moving forward for making the model more refined. So all this information you will be able to see. Now these are the list of references which have been used for in various slides, and also I would like to suggest you to download these papers and go through. Then you will get more clear idea about application of digital human model, creation of digital human model. This is the list. So thank you.